Today I'm going to be talking about yarn softness. So if you can feel the yarn and see it, that's sort of the best way, the best option for buying yarn. So I definitely fully support local yarn shops and fiber festivals. If you can buy yarn at those places, that's the best option. But in the modern world, I know that's a lot of yarn is bought online. And in this video, I'm going to be talking to the people who buy yarn online, or at least some of their yarn online, and make an argument for a better way of sort of measuring the softness of yarn than photos, or a lot of people will say this is super soft yarn, but that's super soft is relative. Like super soft to one person isn't going to necessarily be super soft to another. So I put on my engineering hat and I looked at different metrics that are available about yarn that could help indicate its softness. And I came up with something called micron count. Now, a lot of you are probably familiar with micron count, and it's typically done by the people who own sheep or whatever animal you're getting the fiber from. They'll send in samples from various sheep, get the micron count back for the sheep, for a particular sheep, and then the factories making the yarn will sort of say, I want this grade of sheep with this micron count, and then they'll make yarn sort of to that sort of range of fibers. Now, the problem is the micron count's often not included in yarn, and in fact, I would say most of the time micron count is not included, and that's fine when it's marketed in person. Like if you can feel it, it doesn't really matter too much what the micron count, you can just go by softness. But if you can't feel it, if you're buying yarn online, I would argue that including the micron count is a good thing. And I don't really expect a bunch of yarn manufacturers to go around and start adding micron count. But the point of this blog is I think that I can explain a few really inexpensive, simple ways for you to measure this micron count. And maybe you'll start putting it in the reviews of yarn online, and you can, then people will look at the various reviews, and, you know, if one person there lists the micron count, that'll help. Like, basically, it's another piece of information. It's not perfect information, but I do think it will help people understand how soft a yarn is. Now, for those of you not familiar with micron count, what it is specifically is fiber, or yarn is made up of many, many fibers. And we can see here, I'm not sure if this is going to show up in the video, but what micron count is here's a single fiber from the yarn, one single strand of hair from the sheep. And that hair has a diameter. So what micron count is it's basically the diameter of a single hair in millionths of a meter. So, for example, merino might have a micron count in sort of in the range of, 10 being a pretty soft or fine merino, 10 microns, and then 25 would be a coarser merino. Now, both of those are merino, and both of them are going to be pretty soft because merino's always soft. But if you were online and you saw a review for, this is 15 micron merino, that would give you a better feel for like how it rates in terms of softness compared to other yarns which have maybe other merino yarns that have a slightly higher micron count. There's all sorts of different ways to measure micron count, and I'll leave a link to a blog where I've filled in a lot more information about that. But sort of at a high level, there's labs that will do it for you, and they use these calibrated, fairly expensive machines to do it. I actually am going to talk a little bit more about that at the end. It's actually not that expensive to have your samples sent into labs, so that's actually something that I'm going to try in the future, and I'll report back about that. But there's a downside that you do have to pay for every sample, and it takes a bunch of time. Now, the tools to actually do this that they use are really expensive. They're like often $40,000 or more. There are some newer ones, and again, probably reference my blog post for all the details on that. But in general, they're more expensive than most people are going to want to pay. But there are some sort of do-it-yourself methods that I'm going to talk about today on how to actually measure the micron count of yarn using really inexpensive tools. In fact, a lot of you probably already have some of these tools at your house, and you might not need to purchase anything. So now I'm going to talk about two different ways that I've measured the micron count of a piece of hair from our llamas. So we've got some llamas, and I put it into this little cardboard holder just to make handling it a bit easier. Our llama was tested before we got it, and it was about 40 to 50 micron. And now there are some hairs that are outside of that, but that's sort of the range of micron count I'm expecting for this llama hair. Now I'm going to measure it two different ways. I was hoping both of them would work really well, and they both definitely work, but they get pretty different answers. They're about 2x difference, and I'm pretty sure I know what's happening. I am planning to send some samples to a lab, and I'll talk about that a little bit later to confirm my theory, but I'll sort of go with my current hypothesis, and I haven't directly proven this yet, but I have a fairly high confidence. So the first method is like super easy. I got this micrometer, and this is something, I think it was about $35 from Amazon. I'll put a link to it in the video description. This is the method that I'm pretty sure is giving me the wrong results, but it's like super easy to use. So I was kind of hoping it would work, and there might be ways to sort of recalibrate these, but all you have to do for this method, and as you turn it, it'll eventually reach sort of a standard tightness. Start clicking, and it says it's 0.024 millimeters, which is 25 microns. So, or 24 microns. So the way that these micrometers work is as you sort of turn this dial, they're supposed to reach a standard tightness. And I can do this over and over on this hair, and it keeps getting, there's 25 microns, and I'll do it a little bit further along, and there's 26 microns. So it's getting a little bit thicker on that end of the hair. If I go to this end of the hair, let's see if it's a little thinner. 24 microns still. So, I mean, it's extremely repeatable, but the problem is that I think it's squishing the hair, and different types of hair are going to have different amounts of squish. And I kind of, like I said, I'm pretty sure that's what's happening. I tested some different things, and things that don't compress at all, like a wire, a very thin wire, get the exact right results with this when I compare it to the next method. But a human hair compresses a little bit. Llama hair compresses more. And then I tried some other exotic fibers that are lighter, which I think would mean they'd compress more, and they were even more different. So that's why I'm pretty sure what's happening here is this is crushing it. And you could try to use like less tension, but the problem is I just don't know how reproducible this is. But like here, if I just try until I can just if I go until the fiber stops sliding easily through the gap, I can get down to, let's try this method. So now I'm not going until it clicks. I'm trying to go something a little less. So right around 50. So now it's definitely got tension when I pull it through there. It's kind of hard to pull through the gap. So now I think it's touching, but it's not compressing it. And right there, I've got 53 microns. I think if you got really good with these, they would work, but there's you've got to find a good way of, measuring your micron count without compressing the fiber. And I think there's you've got to handle things delicately. And I'm not the best at delicate. I was just hoping, anytime I measure something with these in machining, you're doing steel parts and you just go till that happens and you're good. But I think with wool or other fibers, you're going to have a gentle hand. And I totally think it's possible. And that's why I'm mentioning it in this video. It's easier to do this method, and I think that the results work. So basically, right, we were getting 25 to microns if I went until it clicked. And if I went until it was just starting to get hard to pull through, I was getting, well, I think it was like 52 microns, right? Maybe 53. Anyways, 52, 53 microns, something like that. Now, I'm going to use an experiment I actually did in college. It's light diffraction and interference. It basically uses the property of light that it behaves like a wave. And we're going to see if we can measure using that method how what the diameter of this yarn is. And I'm pretty sure, I mean, this uses basic physics, so this method is very accurate if you can measure things pretty accurately. The more accurately you measure things, the better this method will work. So this one has a pretty good results in my head. Like this one, I'm worried about it crushing it. This light diffraction one, it's gonna give us the right results. So for this method, you need a laser pointer. And I picked this one just because it has a button that leaves it on. I think it's actually meant for a gun. But on Amazon, I mean, even if you have a cat laser pointer, that'll work fine, especially if you have two people. But I only had one person available for recording this. So I just bought one on Amazon that I could turn on and I could set down and not have it move around much. And then I used this thing, just holds the fiber. That's all that this little contraption is doing. So I put it in that frame before, and the hair fiber is right there in the middle. And I'm not sure if you can, yeah, you can see it barely on the video, but it's easy to see when the laser is hitting the hair and when it's not illuminating the hair. And if I go here, you can see it's hitting the hair. So once you've got that, you need two measurements, basically. You need to know the measurement from the hair right there all the way over to where it's hitting the wall. And you can see I had a target set up. I moved the laser, so I'm just going to move the target now so that it's hitting this. And so you need the distance from the hair to the laser. And I just measured that using a tape measure like this. I just measured from there to from the hair to the target, and that was what was that? 265 inches. And then for the next step, I'm going to turn off the lights so you can better see the diffusion pattern. But let me turn off even more lights. So hopefully you can see, I'm not sure if you can see the dark part, but basically you can see the center of the laser, which is right there. And then it drops off and gets dimmer, and then it gets brighter again. I'm going to include a photo if it's not showing up in the video here. You want to measure from where it's getting, from that bright center to the middle of the first dark patch. That's the second measurement. And you just want to measure it with the same units that you measured the first measurement. So I measured from the wall to the target in inches, then I'll measure from that center dot to the dark region in inches as well. So here's all the information you need to calculate the diameter of the hair. It's basically the wavelength of the laser, and oftentimes lasers will note what the wavelength is. If you don't have a wavelength for your laser, most of the laser pointers are going to be either red or green, especially the cat ones, which I think are maybe the most popular for this audience. But if you have a red one, just use 650 nanometers. And if you have a green one, use 532 nanometers. And then you're going to divide that by the two distances we measured. So one of them is the distance between those light and dark patterns on the target, and then the other one is the distance to the wall. So I had a red laser, and it came with the nanometer wavelength, so I knew it was 650 nanometers. The distance between that light and dark pattern for me was 3.32 inches, and the distance to the wall was 265 inches. And those are all things I measured. Now, I don't like mixing units, but I didn't have it would have been nice if I had a tape measure with centimeters, and I could convert these inches to centimeters if it made me feel better. But if you've had any physics courses, you know that units will cancel when you divide them out. So basically, if I used inches or centimeters, as long as I used the same for both of these distance measurements, they're going to cancel out. And the final answer is going to be in nanometers. So what I did here was I just left them in inches, and I took the 650 nanometers, I divided it by the two distances I measured, which I plugged into that equation, and I ended up with exactly 5,300 nanometers, which, if you go from nanometers to micrometers or microns, it is 53 microns. So I think before we measured, when I wasn't squishing the yarn with the calipers, I believe it was 52 microns. And now I'm getting 53. So those are really good. But it does really show that I think that the micrometer, which we used in the beginning, right here, does sort of crush the hair. I mean, I think both methods work, but the micrometer is easier because you don't have to do any math, but it has sort of more finesse to it. I think it's probably something, if you did it a lot, you'd get really good at it. But I'm just a little worried if you don't have the right touch, or you could easily get off by, 10 microns or something, which isn't, the end of the world, but it can certainly happen. So now I want to mention a little bit about the testing labs that you can send your wool into. They're not actually that expensive. I found one in the US who will do my samples from yarn for $5, and I haven't sent them in, so I'm not going to talk too much about this. I'll probably do a future video on it, and I'll have a blog post that does have information that I've learned from these yarn testing facilities already, or I guess they're fiber testing facilities. They generally test wool from sheep, but the one I talked to said, yeah, we'll test your yarn. The machine isn't exactly calibrated, so they can't guarantee it to have the right results, especially if it's from breeds that aren't, their machine is specifically calibrated for alpaca and wool, but sheep and alpaca, but it'll handle other breeds fairly well, they said. They're just not, they can't certify it for export when you're using these other systems. So anyways, these facilities will measure a whole bunch of fibers and give you sort of an average width across the whole bunch of tested fibers and a bunch of other information. I'll talk about that more in a future one. But I mean, that's sort of the gold standard. If you're willing to wait a little while and send your sample in, I definitely suggest using these lab testing facilities. I'm going to do that and sort of compare against my home measurements. I'll probably measure my samples several times and kind of get my own average for yarn width using the light diffraction method, which I feel more confident about. And maybe with the micrometer as well. I still think about that a little bit more on how much I want to suggest that method. But if I do blind tests where I don't know which one it is, and I can try to see how good of a feel I can get for the micrometer that way. But anyways, these labs will give you really good results. They'll give you a histogram of like how thick different samples or different fibers are in the sample that you give them. And that information is actually really valuable. I'll talk about that in a future video. But I do think just these methods that I've shared here today, especially the light diffraction one, will measure the width of a hair accurately. And if you do a few of those, you'll get a sense of an average, and you could do that for yarn and then put up your review online and say, it's pretty soft. I measured the micron count and the yarn was blah, because most yarns don't have that. And I think if you put that information in an online review, other people who are looking at that yarn who've seen this video or something similar will be able to garner more information from your reviews. So hopefully you guys in the fiber community have found this useful. And thanks for watching.